All right, P helps with Unit 3, Topic 3, Lesson 4, Sums and Differences, Identities. These do take quite a bit of time, which you're going to see why I'm not going to be doing all of them for this video. Starting on with the warm-up, it says express the angle of the sum and differences of special angles. So if we have 15 degrees, then how can we get 15 degrees? In this case, we could say that 15 degrees is the same thing as 45 minus 30. Now, why are we using 30, 45, and 60? Because those are hopefully the three special angles from a triangle that you have memorized for sine, cosine, and tangent, because that's going to become very important in this video. So how do I get 75 degrees? So 75 degrees will be the same thing as 45 degrees plus 30 degrees. And then 165 would be the same thing as 120 degrees, which is the same as a 60-degree angle, if you remember. So 120 degrees plus 45 degrees. 105 degrees, over here. So 105 degrees will be the same thing as, how am I going to get that? So one way of doing this would be a 150-degree angle, which is a 30-degree reference angle. And then you could subtract 45 degrees from it. So that's my way of doing that. Adding the following fractions. So whenever you're adding fractions, you have to have the same base. So you just make them to the common denominator times 3. That's 12 here. So times 4. 3 plus 4 is 7/12. 1/2, the common denominator is 6. So that's 3/6 plus 2/6, which is 5/6. And then the same thing for the last one. So this 12, 3/12 minus 4/12, which is negative 1/12. All right. So these are the two identities right here. This is sums and differences identities. I'm not going to go into a way of proving that the identities work or the reason why they are what they are. That's honestly a little bit above my head. So we're just going to take the identities as they are. When you're looking at these two identities, because we have sine of two numbers and cosine of two numbers, so what you'll notice is that the sign has been flipped right here. So that actually means that you're always going to use the opposite of whatever you see. So for cosine, you always use the opposite. So for this question, you're going to use addition. And for this question, for cosine, you're going to use subtraction. For sine, you use exactly what you see. Sine, you're going to use addition, and sine over here, you're going to use subtraction. So that's what this plus or minus symbol and this flipped plus or minus symbol, that's what that really means. So this can be long and tedious, but honestly, it's really not that difficult. So a couple things I'm going to mention beforehand. Now, remember, a 210 degree is actually a 30-degree angle in the third quadrant. And a 45-degree angle, well, obviously is a 45-degree angle in the first quadrant. So I just like to write that up there so it's in the third quadrant, because if it's sine in the third quadrant, just keep in mind that it's going to be a negative answer. All right, so I'm going to use this blue one right here. It's going to say that sine of u will be 210 degrees, and v will be 45 degrees, is equal to sine of u. So that's sine of 210 times cosine of the other number, 45, plus, because remember, sine is exactly what it is, cosine of u, so that'd be cosine of 210 times sine of 45. Now, once again, you should just have these 30, 45, and 60s memorized. This is a 30-degree angle in the third quadrant, so sine of 30 degrees is square root of 3 over 2. I'm sorry, sine of 30 degrees is 1/2, so it's in the third quadrant, which means it's going to be a negative 1/2. Multiplied by cosine of 45, which is square root of 2 over 2. It's in the first quadrant, so I don't have to worry about that. And then add that to cosine of 210 degrees. Remember, that's a 30-degree angle in the third quadrant. Cosine of 30 degrees is square root of 3 over 2. The fact that it's in the third quadrant, which means it's going to be negative. Multiplied by sine of 45, which is square root of 2 over 2. Okay, so now it's just a matter of simplifying. I'm going to multiply over here, and then add the two answers together. So I multiply over here. Negative 1 times square root of 2 is negative square root of 2 over 4. And then add that to negative square root of 3 times square root of 2 is negative square root of 6 over 4. And then add those two together. Well, you can't add the two radicals technically, so negative square root of 2 minus square root of 6 over 4. That's your final answer. You can't do any simplifying. All right, one more of these. I'm going to go to the next slide because, like I said, these do take time. I do want to do an example of a cosine question, so let me do this one, especially since it has radians. Keep in mind that, remember, anything that's broken into thirds is 60 degrees. 60 times 2 is 120. So this is 120 degrees, which, remember, of course, is in the second quadrant. And pi over 4, of course, is 45 degrees, which means it's in the first quadrant. All right, so I'm more familiar with degrees, so I'm going to leave it as degrees. So cosine of 1 with subtraction. So I'm going to use the yellow one now. So that's cosine of the u, which is the 120. Cosine of 120 times cosine of 45. And now keep in mind that cosine's always the opposite, so this minus becomes a plus. And then sine of u times sine of v. Sine of 120 times sine of 45. Okay, so cosine of 120, we'll keep in mind that 120 is actually a 60-degree reference angle. Cosine of 60 is 1/2, but in the second quadrant, which only sine would be positive, so that's negative 1/2 times cosine of 45, which is square root of 2 over 2. And then add that to sine of 120, which would be positive 1/2, because it's in the second quadrant, times sine of 45, which is square root of 2 over 2. All right, so now it's just a matter of simplifying both sides. So that's negative square root of 2 over 4 plus square root of 2 over 4. All right, add those two together. I feel like that wasn't supposed to. It seems like I found my mistake. I knew there was something here, so this one was wrong. Sine of 60 is square root of 3 over 2. If my pen would work. All right, it always does this whenever I pause. Try this again. Oh, okay. Square root of 3 over 2. Square root of 3 over 2 times square root of 2 is square root of 6 over 4. And I'm going to have to reset my board. All right, so I think I got it now. So square root of 3 times that would be square root of 6 over 4. And then you've got your answer, just negative 2 plus square root of 6. I'm sorry, negative square root of 2 over square root of plus square root of 6 over 4. And that's as far as you can simplify it. All right, due to time constraints, I'm going to move on to tangent. So tangent is done just kind of similar to sine and cosine. I'm going to use this one right here. Now, all this is in pink is just a simplification. So it changes this to this. Well, sine is really just, sine over cosine. So it changes this using that, the sine of an angle over here on top and cosine of an angle on the bottom, because remember cosine is always the opposite on the bottom. And then it changed that to this and that to this. Okay, so this is what I'm using right here. So tangent of u, so that would be, keep in mind that the top is sine and the bottom is cosine. So the top we're going to use exactly the symbol as it is, plus. And then on the bottom, we're going to use the opposite, which is minus. So one side should be plus, the other one should be minus on top and bottom. And if it was minus, then minus would be on top and the plus would be on the bottom. All right, tangent of u. So that's tangent of 120. That happens to be plus tangent of 45 over 1 minus tangent of 120 times tangent of 45. All right, so remember 120 degrees is a 60-degree reference angle in the second quadrant, which means tangent is always going to be a negative. Tangent of 60 is square root of 3. So it's negative square root of 3 plus tangent of 45 is 1 over 1 minus, this happens to be negative square root of 3. Let's see, negative square root of 3 times 1. Simplify that down, so that gives me negative square root of 3 plus 1 over 1 plus square root of 3. Now, for those of you probably wondering, why aren't I going to radicalize this? Because I really can't, because it's a part of an expression. So I just leave it the way it is, and that's your answer. Okay, use a sum of difference identity to find the exact value. So this question basically is kind of similar to what I had already done. Only difference is it's now sine of 15 degrees. It's not 45, it's not 30, it's not 60. So what I need to do is I need to change this to sine of, just kind of like we did on the warm-up, which would be, how could we get 15? So that would be 60 degrees minus 45 degrees would be 15. So then I can solve the problem out from there. So using sine, so that would be sine of u, sine of 60 times cosine of 45. That would be minus, because it stays the same, cosine of 60 times sine of v times sine of 45. And then I work it out from there. So sine of 60 is square root of 3 over 2 times cosine of 45 is square root of 2 over 2 minus cosine of 60 is 1/2 times sine of 45, which is square root of 2 over 2. Okay, so now this becomes square root of 6 over 4 minus square root of 2 over 4, and that simplifies down to just square root of 6 minus square root of 2 over 4, because they're both over 4. And that's your answer for this question. Like I said, due to time constraint, I'm already at 11 minutes. I can't do all of these questions, but it would do exactly the same thing. So let me just get you started. So to get tangent of 15, you're just going to do tangent of 60 minus 45, which means then you'll plug it into this green equation right here. So tangent of 165, so let's see, I need a way. All right, so I pause it again, but that is going to just be tangent of 120, which is basically, remember, a 60-degree reference angle, plus 45. So then you'll just use the green one right there and solve it from there. All right, moving on to the last topic. I forgot to get rid of this. So you can already see the answer, so I might as well just leave it there. So write the expressions of sine, cosine, tangent. So basically this is the opposite of what we were doing. Now we're given the expression. So we're given it set up like this, and we're trying to rewrite the equation to begin with. So it's tangent. So I look down here. Tangent is always tangent of u plus, so it's usually whatever it's written there, which happens to be minus. So it's tangent of u minus tangent of v. So that must be u and that must be v. So I put that in the u spot, put that in the v spot, and it's subtraction because the top is always the same as it normally would be. And then 43 minus 39 is 4. So we found basically that was the question, and this was kind of like the answer. It's kind of like we were halfway through the answer and we went backwards. And then same thing for this one. So it's tangent. So you know it's 299 plus 82, which goes right here, and then add those two together, you get tangent of 391. For sine, remember sine is always exactly what it is, so you know that's subtraction. If it was cosine first, then you knew it would have to be the opposite of that. Since sine was written first here and sine's written first here, so there you go. Sine of 22 times cosine of 38, so you know that u was 22 and v is 38, and then you plug it in, and you can change that to sine of negative whatever that ends up being, which I believe is 16. 22 minus 38, yeah. Okay, I'm going to stop it right there. Thanks again for watching, and there will be another video for sums and differences, and then we'll get to doubles, and that'll be the last one. Thanks again for watching. Have a great day.